So this question asks us to identify true statements about set membership and subsets. And so the real key to this question is understanding some notation. So when we use this symbol here, I'm going to change my pen color. When we use this symbol, either this kind of sideways looking U with a line under it, that means is a subset of, and this sideways looking U with no line, that means is a proper subset of. And so that is when you're talking about sets, so talking about one set compared to another set. And then when we use this kind of funny shaped E, then that's talking about when an element is, so you're talking about you have an element of a set. So on this side you have an element, and on this side you have a set. So you're talking about whether that item on the left, the element, is an element of that set or a member of that set. When you're writing this symbol, you're writing set and set. So sets are on both sides, whether you're using this one or this one. So it's just, that's first of all, and I'll kind of address this as we go through these things. So when we look at this very first question, you're supposed to identify, choose the one that's true. So this first one is saying this set, the set that just contains H, is a subset of this set. Well, the one on the left is a set that contains H. The one on the right is a set that contains H and K. So this is definitely true that this one is a subset of the other set. This one is definitely not true. And the reason it's not true is H is an element. H isn't a set when you write it that way. So if I were going to write something like this, the way you could correct it would be to say H is an element of the set that contains H and K. So first one, that's correct. That one's not. Second one, it says 5 is a subset of the set containing 4, 5, and 6. Well, 5 by itself is an element, not a set. So this is not correct. Definitely no. If I wanted to make this correct, I could say this. The set containing 5 is a subset of the set containing 4, 5, and 6. So the reason this first one's not correct is I don't have the curly braces around it, so therefore it's not even a set, it's an element. Here, this one turns out to be correct because what this statement says is that 5 is not an element of. So for any of these symbols, if you put the slash through it, it just means it's not whatever that says it is. So that little E thing is the element notation. So we're saying 5 is not an element of the set containing 4, 6, and 7. So that's a true statement. Let's see here. This next one, excuse me. This next one, we have this first one. It says the set containing 9, 11, and 13 is an element of the set containing 1, 3, 5, 7, ... Well, that's definitely not true because the left thing on the left is not an element, it's a set. So that one can't be true. So we assume this other one's true, but we're going to verify that. So this one says the set containing 9, 11, 13 is a subset of the set containing 1, 3, 5, 7. And remember, these dots means it goes on and on. The pattern continues. So this set over here on the right, or maybe I'll write it this way. This statement really says the subset 9, 11, and 13 is a subset of the set containing 1, 3, 5, 7, 9, 11, 13, 15, 17. So the fact that this goes on and on and on, there's the 9, 11, and 13 right here. Dot, dot, dot. And you don't have to write everything there just to show that. But sorry, I ran out of room. It won't let me write the end. There we go. And so you don't have to actually write every one of those, and there's a dot, dot, dot that won't let me show up at the end. But the point is I'm just verifying that every element of this set is also an element of this set. That's what it means to be a subset of. So for question D, we have the element notation both times. So we can't be talking about a set on the left. So this is the only one that stands a chance of being correct. That M is an element of the set containing M and R. And so that is a true statement on what I just scribbled there. I'll erase that. All right, so the eraser's not working now. At any rate, that's a true statement. M is an element of the set containing M and R. The reason this one is not true is because that says the set containing M is an element of the set containing M and R, and that's not a true statement. What is true, using those two sets there, is that the set containing M is a subset of the set containing M and R. So really, like I said, this problem is about understanding element notation, set notation, and that when you're writing this subset of, you got to be talking about sets on both sides. If you're talking about an element of, with this guy, this E, you have to have an element on the left and a set on the right.